Powerful examples of traditional building techniques have been shown to be effective during disasters in Haiti, Japan, India, and other nations. In some cases, traditional building techniques are beginning to be recognized, often supported by the UN. Now let's turn back to the UN Words into Action report and its question. The report's second answer is that, quote, around the world, lingering colonialism and racism are further reasons why traditional knowledge is not recognized or mainstreamed to the appropriate extent. Traditional and indigenous knowledge is often dismissed because it is labeled as backwards or uncivilized. In other words, it's dismissed because of where the knowledge comes from, but not necessarily due to the merits or utility of the knowledge itself. Now let's look at the UN's third argument. The UN Words into Action report argues, quote, mainstream DRR has a problem with the very ontology and epistemology of traditional knowledge, which is still largely disregarded in favor of technical approaches and expert, scientific, or Western knowledge. So it's not just about racism, but about different ontologies and epistemologies, meaning fundamental beliefs about what exists to be known and how knowing should happen. To explore this relationship between traditional indigenous knowledges and Western scientific knowledge, let's revisit the Cascadia subduction zone. So we know Thrush and Ludwin argue that colonial researchers learned of but dismissed indigenous seismic knowledge because of the type of data, because of who created this knowledge, because of how the knowledge was communicated, and because of how it was used to strengthen indigenous communities. Modern science has norms and rules that govern who can do science, what counts as good data, and how to present and share this information. And indigenous knowledges were not intelligible within the framework of modern science as a social institution. What is a social institution, though? Social institutions are the norms, values, and rules of conduct structuring human interactions. In other words, institutions are standardized ways of doing things as actions become regularized, patterned, and reproduced. Other social institutions are the family, education, religion, economy, and the government. Institutions are all around us. We're part of them every day. Let's look at the example of education. Education is standardized in Canada. Roles like teacher and student have expectations about how each will act and what they are responsible for. And the education system meets societal needs by passing on knowledge and socializing young people. The education system also holds norms and values like responding to authority, competing for grades, being on time, and so on. And education provides order and stability. Youth are required to be at school certain hours and to learn government-sanctioned curricula. And this is very different from when education used to be done informally in the family. Now, institutions can also be contradictory. At times, they help society run smoothly, and at other times, they reproduce social inequalities. Think, for example, of times and places where women are not allowed to go to university, or where schools have been racially segregated, or when Indigenous children were forced into the settler colonial education system through residential schools that were designed to destroy Indigenous culture, language, religion, and family structures. So that's just one example of education as a social institution. So how is science a social institution? Can you identify some scientific norms, values, and rules? Science has roles like researcher, principal investigator, research participant, and each has expectations about how they will act and what they are responsible for. There are also specific credentials required to contribute to scientific centers like think tanks, universities, and labs. And there are norms and values within the scientific community about things like objectivity, skepticism, and peer review. Modern scientific disciplines have specific terminology or jargon that only insiders trained in the discipline can understand. Scientific papers are written in ways that conform to disciplinary style norms and are often published behind the paywall of an academic journal. How does modern science meet societal needs? Well, for example, modern science tries to solve important questions and generally to improve the quality of life. But of course, other institutions like the economy and politics are involved in defining what those good research questions are and what a good life looks like. Science has the potential to both reduce inequality and at other times reproduce inequality, depending on how research is designed and how it's used. We've seen science used to bolster racism, for example, when scientists measured skull size and argued that some races were inherently smarter than others. It is hard for institutions to change because they are deeply rooted in their patterns, but they always have the potential for change. For example, the institution of the family used to legally exclude same-sex marriage, but this was changed in Canada in 2005. With regard to science as a social institution, the UN Office for Disaster Risk Reduction argues that modern science can and should coexist with traditional Indigenous knowledges. Specifically, they argue that the weaknesses of one system can be addressed by the strengths in the other. For instance, traditional Indigenous knowledge contributes to scientific understanding by providing localized information such as on-the-ground verification of science. Traditional knowledge also makes scientific knowledge appropriate to the local context. And modern science can support traditional knowledge. For example, unprecedented global environmental change means that local communities are experiencing disaster events, the magnitude of which extend beyond the community's lived experience, and by inference, their traditional knowledge. Working toward the coexistence of scientific and Indigenous knowledges requires us to acknowledge that modern science is not the only way of knowing. In fact, modern science is a recent creation. It was developed at a specific point in time and is based on specific assumptions and power relations. So let's look at the history of modern science. Now, when we're talking about science, we must recognize that knowledge of nature's patterns and processes has been found globally within many civilizations, past and present. But the modern science that we know today was born in the 17th century. As modern Western science as a social institution developed, it had to fight for power against existing institutions like religion. The religious worldview of the Renaissance placed immense restrictions on scientific findings. For instance, in 1633, the Catholic Church sentenced astronomer Galileo Galilei to lifelong house arrest for his scientific claim that the Earth revolves around the sun. This period of restriction continued until the Enlightenment, when the evidence building up against religious doctrine emerged quickly and drastically from scholars around Europe. Many historians see the scientific revolution of the 17th century as the precursor to this Enlightenment. The scientific revolution was a period of profound change in human understandings of the natural world. Dominant paradigms shifted from traditional and religious beliefs and authority-based knowledge to empirical observation, experimenting, and the development of scientific theories. Scholars adopted empiricism, proposing the idea that theories should be based upon human observations and experience. And in doing so, they revolted against religious restrictions. This new definition of knowledge permeated every aspect of human society. To any claim, the automatic Enlightenment response was, prove it, and prove it using the scientific method. In this way, the Enlightenment's emphasis on reason and skepticism laid the groundwork for modern science. Now, modern science is believed to be objective and neutral, not influenced by culture, but Thomas Kuhn disagrees. Kuhn argues that even modern science is constrained by paradigms. Kuhn was an American physicist, historian, and philosopher of science. He's well known for his work called The Structure of Scientific Revolutions from 1962. In this book, Kuhn proposes an alternative way of understanding scientific developments. When Kuhn was writing, the dominant view was that science was a cumulative, linear process in which individual scientists built on the work of the scholars who came before them. So science is seen as an accumulated body of knowledge. Each scientific finding is like a brick structure that keeps being built. This conception of science sees individual scientists as the bricklayers. But Kuhn disagreed. He argued that science did not evolve in a linear, cumulative way. Rather than this imagined slow and steady growth, Kuhn found that scientific changes happen as sudden revolutions, and that these revolutions were structured by scientific communities. We call this perception of science as structured and revolutionary the Kuhnian model of scientific change. What does Kuhn really mean by this? Kuhn argues that scientific findings are deemed acceptable through processes like grant funding, peer review, journal publication, professional bodies, curriculum, insular communities with specialized language, and so on and so on. So scientific findings are essentially filtered through the dominant scientific paradigm, governing ways of thinking in that particular time period. A paradigm is in place when the scientific community agrees upon ways of seeing that guide appropriate research questions and answers, appropriate methodology for pursuing those questions, as well as the methods and instruments that will give the answers. For example, Newton developed laws of motion and gravitation. And these laws controlled physics for 200 years because of their explanatory and analytical supremacy. Then, slight inconsistencies were discovered, which Einstein's theory of relativity explained perfectly. The end result was a paradigm shift from Newton's force of gravity in a flat, infinite universe to Einstein's curved space-time. If we think about Kuhn's model of scientific change in the context of the sociology of science, we can see how science is a community activity and how truth is dependent on the social context in which scientific knowledge is produced. So paradigms influence what and how we can see. With that in mind, disaster studies scholars argue that several fundamental assumptions underlie the modern sciences today, and therefore underlie disaster studies.